Hello everyone, my name is Muhammad Izul Ihsan. My student ID is 1525056 and I'm from class 15 to A06, majoring in informatics. Today, I'm going to deliver an academic presentation regarding a journal review in the field of data security and blockchain technology. This presentation is strictly prepared to fulfill my university course assignment. Now, let's move on to the next slide to see the detail of this source material. Let's look at the parameter and metadata. On this slide, you can see the detail of the journal. The title is Applications and Challenges of Blockchain Technology in Data Security and Data Governance, published in 2024. Regarding the authors, it was written by Zilideng, Donghan, Jingwei Sun, and Peng Sun. Furthermore, it was published in the Academic Journal of Computing and Information Science, Volume 7, Number 6. And lastly, the reviewer is me, Muhammad Izul Ihsan, from class 15 to A06, majoring in informatics. After knowing the source information, let's analyze the main problem discussed in this paper by comparing two different storage systems on the next slide. The architecture of vulnerability versus the decentralization solution. First, let's look at the centralized storage as the problem, where modern IT networks house confidential data in singular locations. This creates a massive single point of failure, heavily targeted by cybercriminals for server attacks and data leaks. On the other hand, distributed ledger is the solution, where the journal examines how blockchain spreads data across simultaneous computer nodes, neutralizing the single target and inherently protecting the broader system. As we can see in the diagram, if you look at the red diagram on the left, all computers connect to one single server, make it a clear target where data can leak. On the right, the purple blockchain network shows how the data is scattered safely. So next, let's see how this network handles hacker attacks in real time. The anti-tamper mechanism, consensus rejections in action. How does blockchain keep data safe? First, it has immediate rejection because data exists across many nodes. Malicious hacking or tampering on a single block is instantly flagged and rejected due to a ledger mismatch. Second, it creates unchangeable audit trails. The system maintains a permanent chronological record of every access and alterations, providing perfect organizational accountability that users cannot manipulate. As shown in the center graphics, when a hacker tries to tamper with one queue, the network automatically flags the mismatch and protect the data. Now, to understand how this works, let's check their research methodology. A three-stage filtration approach to the research. For the step, uh, the research did not propose a new software framework. Instead, they synthesized existing deployment through a structured diagnostic lens. Further steps is uh, Further steps, stage one is literature review, harvesting published scientific papers focusing on healthcare, IoT, and mobile ecosystems. Then, stage two is application analysis, examining real-world deployment projects in highly data sensitive fields to verify theoretical performance. And finally, uh, there's stage three is challenge mapping, extracting the core, persistent struggle, slowing adoption to guide future scientific inquiry. These three steps process ensures the study covers both theory and reality by mapping current problems. Now, let's look closer at the specific sectors where this utility is verified on slide 6. Verified utility across data-sensitive sectors. The studies shows that blockchain is already used in many important areas. Uh, First of all is healthcare systems. Secures highly confidential electronic health record or AHR database against unauthorized theft and manipulation. Second, smart IoT devices ensures correct tamper-free data transmissions across interconnected smart home panels, sensors, and hardware. And third, mobile applications guarantees the integrity of safe payment logs and builds highly reliable and manipulable network connections. These three boxes prove that blockchain is highly applicable in daily technology. However, to be objective, we must weigh its pros and cons on the next slide. Critical appraisal weighing viability against depth. Let's start with analytical strengths. It is practical relevance, tackles urgent, real-world industry problems rather than dry theories. Inclusive scope, broad comparative view across healthcare, IoT, and mobile platform. Unbiased, honest about technological limitations. Accessible, open access publications remove paywalls. On the other hand, the methodological weaknesses are no custom framework, functions purely as a summary without introductions, new propria- proprietary tools. Superficial depth spans only 5 pages, preventing depth technical dive into single systems. And three, source verification. Heavy reliance on Chinese language reference restricts global verifiability. This balanced scale visual shows that while the journal has uh, excellent practical insight on the left, its depth is limited by its page count on the right. Next, let's see the detail of these technical limitations on the slide 8. Friction matrix, key roadblock to global adoption. Despite immense safety benefits, blockchain remains a work in progress. Mass adoption is currently stalled by three critical barriers. First, processing speed is at 85%. High barrier technical limits restrict the rapid handling of massive enterprise database. Second, energy consumption 70% significant. The environmental and operational cost of nodes consensus remains excessive. And third, national regulations 60% moderate. A lack of unified data laws creates legal ambiguity for global integrations. The blue bar charts clearly illustrate that processing speed is the biggest hurdle we need to solve. To overcome these three barriers, the paper provides a clear roadmap on slide 9. The integrations roadmap for future viability. To fix these problems, the paper suggests three steps for the future. We must we start with step 1, scalability. Develop and rigorously test new architectural design engineering specifically to support massive enterprise database without crashing. Then we move up to step 2, integrations. Combine decentralized, combine decentralized chains with cloud computing and AI algorithms to balance top-tier processing speed with total security. And finally, step 3, standardizations. Analyze international regulatory frameworks to establish unified data laws and global compliance standards. By climbing these three steps, blockchains can become globally viable. This brings us to the final conclusions of this presentation. The conclusions on decentralizations. In conclusion, blockchain technology is no longer a theoretical concept. It is a highly viable defense mechanism against the systemic vulnerabilities of centralized IT. While heavy processing demands and regulatory frictions prevent it from being an immediate silver bullet, its capacity to enforce absolute accountability makes it the inevitable it the inevitable future of data governance. These strong conclusions wrap up my analysis of the paper. So let's move to the last slide. Okay, so that's it for my presentation. I hope this review helped you understand how blockchains can strengthen data security and governance. For the records, the journal reference is Zheng et al. 2024 from the Academic Journal of Computing and Information Science. And that's it. I'm Muhammad Izul Ihsan. Thank you so much for your time. So, bye bye.